All right, welcome to the next video where we're going to be talking about heating and cooling curves. And for these, it's just really being able to look at this picture and understand what's happening. We've talked a lot so far about this word temperature. And really what temperature relates to is kinetic energy or the speed. And with that in mind, this graph becomes really easy to understand. So from point A to point B, the one thing that we can read just based on the chart is that temperature is increasing. Okay, that's just reading charts. From B to C, what we can realize is temperature is constant. Okay, is constant. So, what do we know is happening? Well, one of the things that's happening is heat is always added. Heat is always being added to this endothermic reaction. Okay, as this graph is happening, the heat source never comes away from the substance. Now, what that means is, well, what that should raise the question of is, if heat is constantly being added, how can you have a section where the temperature doesn't change, such as this section of B to C or the section from D to E? Right? And the answer is actually really simple. The answer has to do with the fact that this section is a phase change. And this section over here is also a phase change. Because what we're doing is we're heating up a substance. We're heating up a substance as if it was starting with a solid, changing from a solid to a liquid in this phase change, raising the temperature of a liquid from C to D, then slowly turning that liquid into a gas here from D to E, and then E to F would be the heating of the gas. This is how you have to be able to read this. Okay? The slanted lines are single phases being heated. Single phase of a solid, single phase of a liquid, single phase of a gas, where the temperature changes. The flat lines, where the temperature has been constant, is a phase change, as I mentioned, right? So this solid to liquid, this is when the melting phase would be occurring on this particular graph. This liquid to gas place would be where the boiling is happening. Now, what you might be thinking is like, well, when things melt, they change temperature. And when things boil, they change temperature. It's not true. The phase change of when you're turning 0 degree ice into 0 degree water, that whole process changes without the temperature changing. And once all of the ice, or once the ice has melted into a liquid, then it can begin to rise up again. So when we look at these charts, we're looking at slanted lines and we're looking at plateaued lines. I say it all the time where, all right, so what's changing here? Oh, the temperature's changing. Well, what does temperature mean? Temperature means kinetic energy. And if you think of it that way, if you think of the y-axis as also being kinetic energy, then it's easy to see that there are only 3 sections on this graph where the kinetic energy is changing. Right? The kinetic energy is changing from A to B. That's where the slanted temperature changes. Kinetic energy is changing from C to D. That's where the temperature changes. Kinetic energy is changing from E to F. Potential energy doesn't change at these sections. You can only change one type of energy at a time. And so if kinetic is changing, which we know kinetic is changing because the temperature is changing, then potential stays the same. A plateau, these flat lines, are the places where phase changes. This is where potential energy increases. Right? Again, what do these words mean? How should we think of them? Potential energy is the distance between the particles. When you go from a solid into a liquid, the distance between those particles does change. It increases in a melting situation. And that's kind of what we deal with when we deal with an endothermic chart. And then on an exothermic chart, aka a cooling curve, we're dealing with the same situation, just in the opposite direction. So everything that we just spoke about remains true. When the temperature changes, the kinetic energy is changing. When the kinetic energy is flat or constant, that's because the temperature is constant. The only difference here is that we flip everything that we were thinking, right? And that means at the beginning of the curve, our hottest, most energized phase of matter, we start with a gas. This gas cools all the way down, losing energy as it goes, until it finally reaches a point where it stops cooling off. And all of that energy that's being released is starting to help the molecules get closer and closer together as it condenses. And surely, once it is fully condensed from a gas to a liquid, the liquid phase starts and the liquid starts to cool. Until that liquid and all of its kinetic energy is released again to the point at which the liquid can now freeze into a solid. So the liquid particles cool off, then they get closer together, then they become a solid. And what do we do with the solid after that? We cool it and cool it and cool it some more. So that is how the heating and cooling curves work.